In this tutorial, we will be discussing how to combine the ideal gas law with stoichiometry. The principles of the reaction of stoichiometry that we learned previously can still be used for the ideal gas laws for the reactions involving gases. In reactions of gases, the amount of gas is often given as a volume instead of moles. Now be careful of the volume, that we have to match that up with R, because volume can be in milliliters or liters, but our R is usually atm.liters, moles, kelvins. It's in liters here. Even if we're using 8.31, which some students might be, it's still going to be in liters. So be careful of what the question's actually asking for. Watch out for that little trick there. As we've seen, you must state the pressure and the temperature of the reaction. The ideal gas law allows us to convert the volume of a gas to moles by using PV equals nRT. We can figure out if we have the volume, we can figure out the moles, the N. Then we can use the coefficient in the equation as the mole ratio like we've done before. So when we're using it in gases, we're going to use PV and T to figure out our moles. And then we use the coefficients to figure out the moles of another thing, and then we can convert it back if we need to, or convert it to grams depending on what the question's asking for. If the gas says it's at STP, that's the only time we can use 1 mole is equal to 22.4 liters. That's the only time. Even if they say it's the exact temperature and exact pressure, that's standard. You can use those numbers and get the same answer as if you were to use the 22.4. But if it's a different temperature than the standard temperature, or a different pressure than a standard pressure, you can't use this number at all. So you can only use this when it says at STP. Let's do a practice one. What volume of H2 is needed to make 35.7 grams of CH3O7 at 738 millimeters of mercury? Notice they gave you the pressure there. And 355 Kelvin, they gave you the temperature. So what you're missing here in this PV equals nRT equation is the N. We're missing the moles. So we go grams to moles, moles to moles, and then from there we're going to use PV equals nRT to get to the liters. So we have a horizontal line here, which means we use the coefficients, and the unit moles are the in caps of the coefficient. So before we do anything else, we need to convert that to moles. 35.7 grams of CH3OH over 1. We need to figure out the molar mass to get from grams to moles. So we have carbon, hydrogen, and oxygen. We have 12.01, 4 times 1.01, and 1 times 16.00. That is all added up to equal 32.05. We got those numbers from the periodic table. So 32.05 is going to go on the bottom, so that way the grams can cancel out. 1 mole of CH3OH is going on top. The grams of CH3 cancel out. Now we're right here in our plan. We're going from moles of one thing to moles of another, and we're going to use coefficients to do that. So we have 1 mole of CH3OH. I know that because that's the coefficient. We're going to H2, so we're going to put 2 moles H2 on the top. We're not going to take it any further because we're looking for moles, so we can put it in our PV equals nRT. And that equals 2.23 moles H2. Now we can use the PV equals nRT. So our pressure is 738 millimeters of mercury. Unfortunately, because our R is 0.08206 atmospheres, liters, moles, kelvins, I need to convert this over. So 738 millimeters of mercury over 1, 760, 1 atmosphere. That brings us to 0.971 ATM. So when our PV equals in our P is 0.971 ATM. Our V is what we're looking for. N is what we just solved for, 2.23 moles. R is 0.08206. And our temperature is 355 Kelvin. We're going to multiply that out. So it would be 0.971 ATM times X is equal to 65.0. And we are only left over with ATM dot liters because the moles and the kelvins cancel out. Divide both sides by 0.971. ATMs cancel out. That comes out to be 66.9 liters. Let's try another one. How many grams of H2O form, so we're looking for grams of H2O, when 1.24 liters, of H2 reacts completely with O2 at STP. Notice at STP. That means I can use 22.4 liters is equal to 1 mole. That's the only time I can use that conversion factor. So we're going from one thing to another. Moles are the end caps. Liters to moles, I can use 22.4 because of the fact that it says STP. And then moles to grams, I need the molar mass because of the unit grams. Okay, so we use the coefficients for this line. I'm going to need the molar mass, so I'll go ahead and solve that now. We have hydrogen and oxygen, 2 times 1.01 and 16.00, and we only have one of those. Comes out to be 18.02. We got those numbers from the periodic table. So 1.24 liters over 1 of H2. Liters on top, so I want to put liters on the bottom. 1 mole H2. 2 moles of H2. Now we're in the coefficients area. There's a coefficient, and we have 2 moles of H2O. And we can go from moles to grams using the molar mass. So for every 1 mole of H2O, there's 18.02 grams. So it's 1.24 divided by 22.4 times 2 divided by 2 times 18.02, and that brings us to 0.998 grams H2O. We're going to have one more practice of these. What volume of oxygen, so X liters, at 0.750 atmospheres and 313 Kelvin is generated by 10 grams of mercury 2 oxide. So we're going from one compound to another. Moles are the end caps. Going from grams to moles, which means we need the molar mass, which I've given you right here. 216.59. If you don't know how that number came about, you need to look on the periodic table and add mercury and oxygen together. And then to go from moles to liters, we're going to use PV equals nRT. To go from moles of one thing to moles of another, we're going to use the coefficients. So there's our plan. So let's set it up. 10.0 grams of HGO over 1. We have grams of mercury oxide on the top, so we're going to put grams on the bottom. Grams cancel. Now we have it in moles, so we're going to use the coefficients. We're right here in our plan. So 2 moles of HGO for every 1 mole of O2. Because we want to use PV equals nRT, we're actually not going to need this last bracket. We don't need to get it to grams. We just need it in moles. So 10 divided by 216.59 divided by 2 comes out to be 0.0231 moles. Now that's going to become our N in PV equals nRT. So our P is 0.750 atmospheres. We don't have to convert that one this time, luckily. V is what we're looking for. N is 0.0231. R 8206. Oh, I'm running out of room. And T is 313. Unfortunately, I didn't have the room to write the units out. So this is moles. This is ATM, liters, moles, kelvins. Alright. So we multiply across. That's 0.750 ATM times X is equal to 0.593. The moles and the kelvins cancel out, so we only have ATMs and liters left. Divide both sides. ATMs cancel. X is equal to 0.791 liters. And that's how you combine gas laws with stoichiometry.